Hey mathematicians, this is Mrs. Shopper coming back to you with section 6.3. This is tests for parallelograms. We're continuing to work on quadrilaterals, okay? So here are some conditions for parallelograms. Make sure that you're writing these down on your note cards. If this happens, then we have a parallelogram, okay? So you can take time to read this right here. And write down that information on your paper. Now, one thing I do want to point out is that bottom one, it says if one pair of opposite sides is both congruent and parallel. So if one pair of opposite sides is both parallel and congruent, then it's a parallelogram. So just take a good look at that one. But take some time, pause the video, get these written down. Okay? So the question is this quadrilateral a parallelogram? The answer is yes. And the reason why it is because we have two pairs of opposite sides that are congruent. So yes, this is a parallelogram. We have two pairs of opposite sides. It's congruent. Okay, we have two pairs of opposite sides congruent. Let's try another one. Which method would prove this quadrilateral is a parallelogram? Okay. Well, it can't be both pairs of opposite sides parallel because we don't know what's going on with one set of sides. Both pairs of opposite sides are congruent. We don't know what's going on with both sides. We don't know angle measurements, so it can't be that. So it's going to be one pair is both parallel and congruent. The answer is D. All right, find X and Y so that the quadrilateral is a parallelogram. All right, so pulling in some algebra here. What do we need to do? What do X and Y need to be so that this is a parallelogram? We're going to set up two separate equations. We're going to say that 4x minus 1 is equal to 3 times the quantity x plus 2. And we're going to say that 3 times y, better give myself a little bit more room, 3 times y plus 1 is equal to 4y minus 2. And now we're going to solve each of those equations to make sure that it's parallel. So I've got 4x minus 1 equals 3x plus 6. I've got x equals 7. So if x is 7, then that's parallel. All right, looking at the other one, I've got 3y plus 3 is equal to 4y minus 2. Y has to be 5 in order for them both to be parallel. Okay. All right, so just again, a summary of what we were talking about to prove a quadrilateral is parallelogram. These are all the different ideas that you can use. If we were doing proofs, we'd want you to be able to apply them in there, but we just need you to know this information, okay? So if I ask you to list, how can you prove a quadrilateral, a parallelogram, you should be able to list all 5 of these with no problem, okay? This is that preparation part. All right, determine whether the quadrilateral is a parallelogram and justify your answer. Okay, so when I have it on here, I can use any way that we want. I'm going to use the slope formula on this one. So the slope of QT is going to be, we're going to rise 1, 2, 3, 4. So the slope is 4. The slope of RS needs to match it in order for it to be a parallelogram. And it does. All right. The slope of TS and the slope of QR also have to match in order for this to be a parallelogram. So T has a slope of -2 or -1/2, I'm sorry. And the slope of QR is down 1, 2, is also -1/2. So we use slopes, okay? Now, you could use the distance formula. You could have said, hey, I don't want to use slopes. I want to use the distance formula and use the distance formula for QR and TS and QT and RS. Whatever strategy you want to use. The opposite angles congruent isn't going to quite work on this one because that's harder, but you could use slope or you could use distance formula. All right. Find all the possible coordinates for the 4th vertex. Okay, this is something that you worked on last year with Mr. Flatness a little bit. but it's finding it. So we know, I think when I look at this, you have 4 different ways to look at it. So pause this, see what you come up with. All right, so one way is to do the parallelogram this way. And so if I look at to get from this point to this point, I go down 1, 2, 3, 4 over 1, 2, 3, 4. I'm going to do the same thing starting at this point. Go down 1, 2, 3, 4 over 1, 2, 3, 4. And there's my ordered pair. So that would be negative 1, 2, 3, 4, 5, 6, 7, negative 7, 0. Okay, now if I wanted to draw this parallelogram this way, all right, so this is going to be a different one. So to get from this point to this point, I rise 1, 2, 3, 4, 5, 6, back 1. Okay, so that's negative 6, back 1. I would do the same thing here. I would go up 1, 2, 3, 4, 5, 6, back 1. So this ordered pair is going to be 1, 8. Okay, or what if I wanted to draw it this direction? Look at that, right? I could have my parallelogram go this way. And so to get from this point to this point, I would go down 1, 2, 3, 4, 5, 6 over 1. So I'm going to start here. I go down 1, 2, 3, 4, 5, 6 over 1. So I drew my lines a little bit off on there, it looks like. Okay. And so that ordered pairs me 1, 2, 3, 1, 2, 3, 4. 3, negative 4. Okay. Now, I want you to think, what do we know about this figure that we created here? Spend some time thinking about this. All right. You have time then to work on your assignment. Thanks for coming along, and I'll plan to see you soon. Take care. Bye-bye.